Imagine how difficult and time-consuming it would be to perform mechanical construction work without an aerial lift. In our business, lifts are critical to our success. But unsafe work with lifts can get us hurt in a hurry, especially if we don't know what we're doing or we're not using safe work practices. Much of our work requires the use of scissors and boom lifts, and most of the safe work practices apply to both types of lifts, but we'll cover the key differences too. Before you trust your life to any lift, make sure you have the proper training for each specific make and model of lift that you'll be operating. Even if you've operated a similar type lift in the past, there are enough differences between makes and models that training is required for each of them. The training should cover an overview of the lift, its load capacity, how to inspect it, how to perform function tests on the mechanical, electrical, and hydraulic systems, what to do when there are problems with the lift, fall prevention and protection, and safe operating procedures. Some of the information you need to know will be posted on the lift itself, but not all of it. You'll need to start by familiarizing yourself with the lift manufacturer's operating instructions. The instructions should always be kept with the lift so that all operators can quickly and easily access them. If the instructions are missing, don't use the lift until you can get your hands on a copy. Next, learn about the manufacturer's rated load capacity and maximum extension parameters, including lateral reach when it's a boom lift. The side load force decal attached to the frame is a great source of information. In most cases, the load capacity, which includes the weight of the lift occupants, their tools, materials, and equipment, will be much higher than what you'll need to perform your work safely. But don't forget, load capacity is affected by the weight of the load and the height of the platform. And if it's a boom lift, the load capacity is affected by the boom angle and the length of extension too. Be sure to check the load charts in the operator's manual. The lift you'll be using needs to be inspected and tested each day before you use it. And be thorough. Your company will need to keep the inspection documentation information for at least 1 year, and it may have to reference the documentation during that period. When you're preparing to work on a motorized lift, start the inspection by checking the fluid levels, including the oil, coolant, and the fuel. When you'll be working on an electrical lift, check the electrical system, including the batteries. Make sure the batteries are fully charged, their connections are secure, and look for corrosion, leaking battery acid, and any other damage to the system. Whether it's an electrical or motorized lift, pay plenty of attention to the hydraulic system. Start by checking the hydraulic fluid level and hydraulic pressure. Visually inspect the cylinders and hoses looking for leaks, cracks, cuts, kinks, and any other signs of damage. Look the entire lift over for structural damage too. Pay close attention to damage that could affect the lift's mechanical systems. The lift's safety features, such as the guardrails, chain or gate, and designated lanyard attachment points for fall prevention or protection, need to be examined as well. And since the lift's rated load capacities and operating characteristics are based on the assumption that the tires are in good condition and that inflatable tires are properly inflated, you'll need to pay close attention to the condition of the tires. When the lift you'll be using has inflatable tires, carefully inspect each tire for damage. Look for indicators of dry rot, cracks in the rubber, nails or other objects sticking into the tire, worn out tread, and damaged valves. Also, make sure the tires are securely attached. If the tires are in good shape, check the pressure in each of them and inflate them to the manufacturer's recommended tire pressure when it's needed. On lifts equipped with solid tires, make sure the tires are securely attached and look closely for splits, cracking, and missing pieces of tread. As part of your daily pre-use inspection, be sure to test the tilt sensors too. The tilt sensors are instruments built into the mobile elevated work platforms that measure the degree of tilt and warn the user when the equipment is tilting too much. The sensors also stop function to keep the equipment from tipping over. The test methods for tilt sensors on mobile elevated work platforms vary depending on the type, brand, and model. For example, to test the tilt sensor on a boom lift like this one, you can do everything you need from the ground level. Simply turn the machine on and open the cover, then push and hold the tilt sensor until you hear the alarm. On other types of mobile elevated work platforms, you may have to park one side of the lift up on 2x4s and raise the platform several feet while listening for the alarm. Or if a ramp is available, you may be able to test the sensor by parking at a slight incline on the ramp and elevating the lift platform to the manufacturer's designated test height. In any case, if the alarm doesn't sound, there's a problem with the sensor, so don't use that lift. Immediately follow your company's procedures for taking defective equipment out of service. The most important thing is to carefully follow the manufacturer's instructions for testing the sensor on the specific type, brand, and model of mobile elevated work platform that you'll be using, and never elevate the platform higher than the test height designated by the manufacturer. You should also test the pothole protector on mobile elevated work platforms that have them. Pothole protectors lower the ground clearance when the platform is elevated to reduce the risk of tipping over if the equipment hits a pothole. To test the protector, slide a 2x4 under the lift at the midway point. From the ground level, elevate the platform and watch for the pothole protector to deploy. The alarm should sound because the 2x4 prevents the protector from deploying properly. If the alarm doesn't sound, don't use the lift. Immediately follow your company's procedures for taking defective equipment out of service. So, to sum it all up, be sure to refer to the operator's manual and follow the instructions for properly testing tilt sensors and the pothole protectors when they're part of the equipment.
When you've completed the inspection and are satisfied that the lift is in good condition, it's time to perform function tests on the electrical, hydraulic, and mechanical systems.
Start by using the ground controls. Run the lift through each function. Listen for unusual noises and make sure the lift responds normally. If everything checks out, get on the lift, close and latch the gate or chain, attach your fall prevention or protection equipment, and run the lift through the same function tests using the remote controls. When all functions are working properly, take one last walk around the lift looking for hydraulic fluid leaks. If there are no leaks, you're good to go.
If at any time during the inspection or function testing process you find a problem with the lift, don't use it and immediately report it to your supervisor.
Place an out-of-service tag on the lift and immediately follow your company's procedures for taking defective equipment out of service until it can be evaluated and repaired by someone who's qualified to do it properly. Most falls from aerial lifts occur when workers step up on the lift's mid-rail, top rail, a bucket, a plank, or something else to extend their reach. Some falls occur just from failure to close and latch the gate or chain. And workers have been bounced right out of their boom lifts because they weren't properly tied off and didn't evaluate their travel route ahead of time.
Let's spend some time on aerial lift fall prevention and protection. Your effective reach is within the guardrails with both feet planted firmly on the platform. With that in mind, if you can't position the lift to get the safe access you need, find another method to access the work area.
Vertical access attachments work wonders in many of the hard-to-reach places. They allow you to extend your reach from the lift into tiny spaces without increasing your risk of falling. And if that option isn't available, use an altogether different approach, such as a scaffold or a ladder platform. To work safely at heights from any aerial lift, you need some sort of fall prevention or protection system. A fall prevention system prevents you from falling in the first place. The two types of fall prevention systems allowed for work with scissors lifts are guardrail systems and fall restraint systems. Guardrail systems are built into all scissors and boom lifts, but fall restraint systems are highly recommended in addition to the guardrail systems for work in scissors lifts, and they're required in many workplaces. But never use a fall arrest system when working in a scissors lift. On the other hand, work in all boom lifts always requires either a fall restraint or fall arrest system. A fall restraint system includes a full body harness and a short, non-shock absorbing lanyard, or a short, self-retracting lifeline, commonly referred to as an SRL. The length of the lanyard or lifeline must be short enough at its maximum length to prevent you from getting into a position where you could fall. Depending on the size of the platform, the fully extended length of the fall restraint lanyard, or SRL, should be 4 feet or 6 feet and never any longer. A fall arrest system is designed for fall protection, not fall prevention. When used properly, the system will prevent severe injury if a fall does occur. A fall arrest system includes a full body harness and a shock-absorbing lanyard that won't allow a free fall of more than 6 feet, or an SRL. The SRLs are designed to prevent free falls of more than just a couple of feet. Whether you're using a fall restraint or fall arrest system, make sure that you properly connect your lanyard, or SRL, only to the manufacturer's designated lanyard attachment point. Attaching it anywhere else could result in severe injury. And always make sure that the gate or chain is closed and properly latched.
To operate any lift safely, the entire lift operations area must be thoroughly evaluated before the lift is used. Driving a lift on an uneven surface, dropping a tire into a small hole, or running over an object isn't usually as big a deal when the lift is in the lowered position. But when the lift is elevated, the difference in the center of gravity can be astounding.
No matter what the cause, whenever a lift becomes unlevel, its center of gravity shifts. The higher the lift goes, the more pronounced the shift will be. Too much shift, and the lift will topple. Lifts are designed to operate on firm, level ground. The best way to evaluate the ground conditions is to walk through the entire lift operations area looking for anything that could make operating the lift in that area unsafe. Look for surface obstructions like pipe, rebar, conduit, and ducts sticking up through the surface. Those types of obstructions could damage tires or destabilize the lift. Remove construction materials, tools, and equipment from the pathways where the lift will be operating. Dispose of construction debris you find in the pathways as well. Identify and mark any holes, ledges, or drop-offs that could destabilize the lift. If there are holes in the surface of the lift operations area, they have to be covered before you move the lift into that area. Floor hole covers must be capable of withstanding at least twice the maximum axle load of the heaviest lift that could run over them. And don't trust existing floor hole covers until you've verified that they are structurally adequate and properly secured in place. Even then, it's best to avoid driving over floor hole covers whenever you can. And be sure to avoid driving the lift through standing water that could be hiding a floor depression or some other hazard.
As you're evaluating the lift operations area, identify any overhead obstructions that could be hazardous.
Pipes, ducts, electrical wiring, HVAC equipment, fire sprinklers, lighting fixtures, anything that could be struck by the lift or an occupant while the lift is moving can be extremely hazardous when you're not aware of them. In high hazard areas, such as when the work is outside and close to overhead power lines or nearby excavations, a thorough task hazard analysis should be performed before using the lift in the area. Be especially careful around energized electrical conductors and circuit parts. If they're present in your immediate work area, verify they're de-energized, locked and tagged out, and tested dead before you move the lift to that area. No matter what type of lift you're working with, Enter and exit the lift only when it's in the completely lowered position. Whenever moving the lift from one work area to another, always operate it from the position that gives you the best visibility. You might need to raise it slightly from the fully lowered position to get adequate visibility, but never raise it more than just a few feet, and always keep it as low as possible while still allowing you to clearly see the path you're traveling. Moving a lift over rough terrain can be challenging. Make sure the lift you'll be using is the right kind of lift for the terrain you'll be working on. Adjust your speed to the terrain and avoid as many of the surface irregularities as you can. Once you're in the right position, verify that the lift is stable and level and that the brakes are set. If the lift is outfitted with outriggers, make sure they're properly set before raising the lift. Since lift platforms provide only a limited amount of workspace, keep your tools, equipment, and materials neatly organized on the platform. Not only will it help prevent you from slipping or tripping, but it will make you even more productive.
Be sure not to use your lift as if it's some kind of materials handling equipment. It's not designed to handle heavy equipment or large quantities of materials.
Remember that the more weight on the platform and the higher the lift goes, the more the center of gravity changes unfavorably. So keep your loads moderate and distribute the weight of your tools, equipment, and materials evenly throughout the lift platform. When you're moving the lift short distances from the elevated position, always check the surface conditions in the direction you'll be moving. Proceed slowly and move only in small increments. Make sure that any power cords, hoses, or welding leads are secured to the lift with breakaway lanyards or slip knots, and there's plenty of slack in them so you can move the lift without putting too much tension on the lanyards. When you must move more than a few feet, or when surface conditions are not ideal, lower the lift as far as it will go down before moving.
By now, you've figured out that working safely with aerial lifts takes quite a bit more than just knowing how to run them.
It requires knowledge about each specific make and model of lift you'll be operating, including their rated load capacities, how to perform daily pre-use inspections and proper function testing, safe work practices, including the basics, like entering and exiting the lift only as recommended by the manufacturer, never using any lift as an elevator or materials lifting device, the appropriate protective equipment for fall prevention and protection, safe operating procedures, and always wear a hard hat anytime you're operating or riding in any lift.
If you learn everything you need to know about the lifts you'll be using, follow the safe work practices and aerial lift operating procedures you learned today, and respect the fact that aerial lifts are complex machines that require your undivided attention, you'll still be very productive, but more importantly, you'll be working safely.